Okay, now it's time for a new domain. Domain number 2, algebra. It's on the test a lot. I'm sorry. A lot of people have problems with algebra, but we're going to try and break it down, make it a little easier, more relatable. Let me give you a brief history and overview. Algebra was invented amidst the Islamic science resurgence of the Middle Ages by a Persian gentleman. The Latinized version of his name is algorithmy. The word algebra comes from algebar, which in Arabic means a reunion of broken parts, which is essentially what algebra is. It can solve very complex problems. It's abstract and representative. It's often a problem for students because of that abstract nature. In order to become good at these algebra problems, you have to practice. What I said earlier about doing problem sets, that applies more with algebra than anything else. You have to do the problems. You got to put in the work. Math is fun. Purple Math, they're free resources with free problem sets. I'd recommend going and doing that. Algebra has a tremendous amount of uses. It's used constantly in computer science for variables. It's foundational. And it's used throughout the rest of mathematics. It's essential. I have a little cartoon over on the right. It says, just a darn minute. Yesterday you said x equals 2. And I think that summarizes a lot of the confusion people have with algebra. Because it is so abstract. You're looking for one answer, and there's not just one answer. So first we're going to talk about variables and substitution. Variables are abstractions or placeholders that can stand for a variety of things like a temp, or any player on the team, or any student. When you say that instead of a specific one, that's essentially a variable. The variable x is probably the most commonly used variable. You will see for a number x or related in a lot of problems, or for any number, that means x, or you could use, sometimes people use n, that's common in single variable equations. Variables enable us to solve a problem once and apply it to specific situations rather than solving it again and again and again each time. Now, the ancient Egyptians, for instance, one of the things they did was, in order to solve problems involving geometry, they had what's called a brute force solution. So when they wanted to figure out a circle, they'd get a peg, they'd hammer it in, and they'd get string. And they'd walk around to make a circle of a certain distance or length, and they kind of did it by eye. They weren't really using the equations. And this was less common towards the end when they were building pyramids and such. But early on, this is one of the things that they did. And that's much less accurate than using an equation. They were solving the problem over and over and over again rather than solving it once and using the equations. We'll learn a little later about the equations for circumference and area of a circle. But if you use that, that's a lot simpler than having a string and a peg and trying to figure, when you're doing your fields or crop circles, exactly, well, where do I stand? You got to do it by eye. If you're using a string and a peg method, that takes a lot of trial and error and a lot of time. And if you're a farmer or something of that nature, you probably don't have that time, so it'd be very helpful to know it. Same thing in architecture. You have to know these equations. If you don't, you can't just do a giant multi-million-dollar project by eye. That's crazy. One of the resources I'd suggest is the books of Raymond Smullyan. He's a philosopher and mathematician, and he wrote books on recreational mathematics. They're great, and I paraphrase them here and there. I'd strongly recommend the book Lady or the Tiger. It's really good. If you've ever seen the film Labyrinth, a lot of the puzzles in that film are actually based on the works of Raymond Smullyan. I'm going to give you a problem, pet shop algebra. There is a pet shop that sells large birds and small birds. Each large bird fetches twice the price of the small one. A lady came in and purchased 5 large birds and 3 small ones. If instead she had bought 3 large birds and 5 small birds, she would have spent $20 less. What is the price of each bird? You're probably scratching your head now, don't worry. We're going to go over it in detail, but As always, please take time out to do the problem. You can press the space bar to pause the video. I'll give you a moment to do so, and then we'll be back. Okay, we're back. Let's go over the problem. All right, now, just like I was saying before with the peg and string, it's not that accurate. You don't want to try with the peg and string all day trying to get the circle the exact right length, or just try and guess what your fence is going to be. But you could try, well, is the first bird $20? And see if that adds up, and the second one's $40, which is twice as much, and that doesn't work. And you could sit around plugging in these values all day. That's not going to be a lot of fun. So let's designate values. The small bird is going to be X, and the larger bird is 2 times the smaller bird. So that's going to be 2X. 20 less is either plus 20 to the right or minus 20 to the left. You're going to stay equal. So what we're going to do is 5 times 2x plus 3x equals 3 times 2x plus 5x plus 20, which is equal to 10x plus 3x, which is equal to 6x plus 5x plus 20. So 13x is equal to 11x plus 20 is equal to 2x equals 20, x is equal to 10. But we're not done, because that's the smaller bird. So the smaller bird is $10. Now, the larger bird is 2 times that, which is $20. So now we know the small bird is $10 and the larger bird is $20. Okay, so I'll leave that up for a second. If you want to review it, you can press pause to stop it at any time. And again, what we did was we took the small bird value, we took a variable, x, and we figured, well, the shop sells small birds and large birds, and we know that the large bird is twice the price of the small one, so 2x. And this woman came in and purchased 5 large birds and 3 small birds. So the small birds are x, so that's 3 times x for the small ones. The large ones are 2 times x, and we have 5 of those. So 5 times 2x, that's the large birds, plus 3 times x, which is the small birds, is equal to the 3 large birds, 3 times 2x, and 5 small birds would have spent the $20 less, so we have to add 20 to that, because since it would be $20 less, we can't have both sides of the equations being unequal. That's why we're adding the 20, if you're confused about that. So then we come up with our 13x equals 11x plus 20. And then we take that 20. We have that right there. We subtract the 11x from 13x. That's where we get the 2x equals 20. Solve for x, x equals 10. And then, so the small is $10. The large is $20. Substitution. When we employ substitution, we replace a variable with a real number. So this is plug and play. We're taking a variable, and they're giving us a real number, so we put that real number in the equation. So if the equation was x minus 35 over 5, and it says for x equals 125, we plug that in. For x, we take out the x, and we put in the x value that's being suggested. We have 125 minus 35 over 5. We subtract. Remember your order of operations. So we subtract. We get 90. We divide by 5, and we get 18. Okay, and that's it for this video, and I'll see you next time.